Okay. I have a team of about 16 people, and I do two different things. Half of my team is working on social media data, social networks. Half of my team work within the health data research. So for health data, we do the real-time big data analytics. For example, currently we are working with Royal Brisbane Hospital ICU patient. We are going to have a sort of intelligent data center watching all the sensors data from ICU patients and connecting all the ICU units wherever, whatever, and then to do the real-time prediction on the risks of the organ failures and the deterioration and also other diseases. And this is kind of research work. And we are getting some funding from industry as well. And this is about health data. For media research, or we call it social media research, I started with these questions. I have about 9 people working with me, and we get some funding as well. UQ, University of Queensland, gave me $600,000 directly from Vice Chancellor. And also I got a couple of LC grants working in this area as well. So it is a very serious business. We are doing research, not this is a research business. So this is a list of driving questions at the beginning. We are doing something called the opinion search engine. So Google search engine is searching for the facts, like pictures, video, audio. They are all facts. But can we search for the opinions? So we are doing some research on the so-called opinion search engine to solve this kind of problem. Anyone expressing any opinion about any product, about any services, how can we search for that? Secondly, we need to consider how can we share the experiences together with sharing the values. I will show some problems within the current social media architecture. And also, the third question is, can we regard data as a value? In other words, can we own our own data? Currently, people go to the hospital, and then when they come out of the hospital owns their data. If I do the booking online, do the business with airliners like Qantas own my data. Then I do the business with Virgin Blue, and Virgin Blue own my data. So wherever I go, those service providers own my data. Can we own our own data as a property? So that is another issue. The last one question is, can we associate or integrate social networks with the Internet of Things? Social networks is connecting people. Internet of Things is connecting the physical objects. Can we put two things together? For example, if I'm booking a restaurant for a table, and that restaurant happen to have Internet of Things connecting their parking slot, and then I can immediately get the parking in that restaurant because that information of availability is available within their website or something like that. So can we link all of those things together? And that is what we are designing, and we are providing a kind of platform can do those things together and within the big data scenario. So that is what we are doing now. And this is one of our prototype system. I think some of you already seen it, and also it is available on the YouTube.
With a great climate, comfortable environment and relaxing lifestyle, our Sunshine State Queensland is the most attractive state to live, work and study in. Wiki Queensland is a system that uses big data fusion to provide a one-stop information service for people such as residents, visitors, local companies, and potential investors to access and share Queensland data. With the fusion of more than 1,400 open data sets, Wiki Queensland can visualise and rank the data in terms of 4 categories: safety, healthcare, education, and living standards. Fingerprint graph reflects the ranked scores at different levels of detail. Local safety scores can be seen in terms of police services, ambulances, and crime rates. Healthcare is ranked based on information such as local age distribution and the average waiting time for surgery at the closest public hospitals. Education is ranked based on available information from surrounding public and private schools such as a student academic performance. Living standards can be described via personal and household incomes, housing prices, and public transport services. In addition, data from social networks such as Twitter reveal local sentiment on current issues. Wiki Queensland, your local expert, knows Queensland better than a Queenslander.
So this is the connectivity between the social media and the actual the web systems. So as you can see, people having feedback. Let me just show you actual feedback people are doing. Like a bottom right, that is social media. We use Twitter at the moment. There are some very hot topics. On that time, it is about end of November in year 2014. And the red colors are the negative opinions. As you can see, a lot of negative opinions there on the UQ campus. And I was a little bit worried about. I asked my students, I said, how can you do that? We are taking this as a competition. My students said, Dr. Li, you told me to use real data. Don't you want to see this? Then I said, okay, let's double click. And on the bottom, there are some actual tweets there. And then I read them. Suddenly I realized the people sitting on the lakeside bus stop twittering something about the bus never come because the bus table has been changed after the teaching week. During the examination, students still there, but the timetable was changed. And there are more people waiting than usual, than normal time. And we do the ranking, and then suddenly we find out that this is an issue there. So as you can see, when we find something, people may don't like to see it. And that is a kind of surprise to people. And this is just one thing. So we needed to find out opinions for the actual sharing the values. And there are so many things about discovery opinions, whether they are the true opinions or not. Sometimes people don't want to talk political issues during the working time, during my friends, amongst my colleagues. But they are more willingly to talk about issues on the social media. By looking at the website called the Pew Research Center, and they said there are about 75% of the social opinions nowadays are available from the social media. So this is a kind of situation we're asking ourselves at the first place. If we use data analytic tools to find out the social opinions, are they true social opinions or not? And this is one experiment not done by me, by another reference. The blue color is actually the Twitter sentiment. The black color is Gallup poll. The Gallup poll is very expensive. Every 24 hours, they invest on random choosing 500 people. And the actual cost is very big because they are doing this manually. But if you do it on the Twitter analysis, it costs you nothing, just a piece of software. And then you can see the consistency between the survey done by human power and the Twitter analysis. And that can give us a kind of justification by using our software to do the analytics. And there are some challenging examples.
Sorry, can I ask a question? The sort of analysis you're doing, are they like open source ways, open source available to look at?
Yes, we use crawler.
Sorry?
Crawler. Crawling on the social media.
That really interests me is how do you cater for sarcasm? So, for example,
Yeah.
I might say, "Thank you very much," and they
That's a very good question, yeah. At the moment, we ignore it. I have a PhD student did the sarcasm and the spamming as well. Yeah, we had a very bad experience with the spamming detection. And a few years ago, there was an election in New South Wales. And I was asking Vice Chancellor to give me the money. He gave me 1 minute. Say, Xue, tell me, why are you asking me for money? How are you going to spend the money? Then I said, okay, 1 minute is good enough. First question, there are 9,000 people talking about UQ. Do you want to know what they are talking about? My second thing I said is, people talking about UQ also talking about QUT, talking about Melbourne University. Do you want to know that? He said, yes, that's interesting. And then I get money. I got $600,000 directly from Vice Chancellor. And then I started doing that. Before they actually gave me money, I filled in the form. And the provost said, oh, by the way, next week there will be a New South Wales election. Can you predict on that? I said, yes, I can do that. If I fail, would you still give me money? And he said, oh, just do it. Okay, let me see. During the work, my student told me he detected about 40,000 messages posting on the internet is injected by a certain political party in New South Wales election. And we're detecting that pattern easily because the same person has a very high frequency on talking about something. Basically, it's a cut-paste. How can you have 200 tweets a day? On the Twitter. Yeah. And also, this person has a certain friends of friends, and they are all politically in the same arena. And we detected about 40,000 of them. And then I told my student, asked me, what do we do with those spamming opinions? Then I made a big mistake. I said, delete it. However, after that, our discrepancy is exactly that, about 4% discrepancy. We still get it right. So far, we predict almost every election correctly. I will show you our further explanation. But we should not delete those spamming tweets because people are affected. Yeah. I played as a god or something, deleted it, shouldn't do that. That's what's wrong. Yeah. Okay. So there are many challenging questions, like these things here. The number 3, you see, with a smiling face, you are terrible. But it's actually your friend saying that. Yeah. And also the last one is people saying this without a sentimental English vocabulary. Stop the boat, for example. And that is not to say good, bad, hate, love, those kind of sentimental words. You cannot find it from the sentiment, we call the scent word net. It's not available, so you must have something else. We call the language modeling. And we regard everyone, every organization, every political party speak differently, uniquely. And we call it a language model. So-called language model is the frequencies of those words happen together, co-occurrence. of the words when they speak by a certain person. And also the first one says, the food was great, but the service was terrible. That is about a restaurant. So negative, positive, both opinions expressed to a certain object. How can we do the summarization for that? So we need to do a little bit of statistics on that as well. And this is from Pew Research Center about the user of the social media is getting more and more people involved and a higher age, like as you can see, and getting more and more people talking about. Here are the issues, people talking about different issues over the internet, over the social media, like politics, sports, music. Music and the movies is the largest number of percent. But we also should understand opinion search is not just search those people who are speaking. There are silent majority. And like a recent experience we had, a lot of people would vote for Trump, but they don't say anything. Why is that? Because Trump have a very bad reputation on treat women. So some people, they want to vote Trump. If they say that, people would accuse him because the characters of the Trump has some problems. But politically, they would like to vote for Trump because they said, we want to make America great again. Those kind of issues. So it is personal characters against the political issues. Which one we weighted in our counting on the prediction of voting. And here is called the spiral of silence. Means if I say something on the internet, doesn't mean I will say it face-to-face to people. And if I say face-to-face to people, it would be differently when I was on the electronic platform. What's that mean? That would imply our work cannot be purely counting on the opinions. We need to do the regression, analyzing on the pool of the people we call the silent of majority, and looking at the historical data, not just purely picking up the Twitter and analyzing it's positive or negative. We're not simply doing that. A simple example is we take the stock market data, a very specific one, and then we do the projection purely based on the mathematics, purely based on their performance. After that, then we use people's opinion to adjust it. And people's feelings, people's attitude to say buy, or sell. That could affect people a little bit. So what we are doing really here is adjustment. And this is our website predicting the Trump. As you can see here, on the biggest Australian website newspapers, and a lot of people congratulated me, say, Xue, you did it absolutely right. On the 5th of November, our website actually predicted Donald Trump would win on the news. And then after that, I get, if you really go to the website, you see some follow-up message. A lot of people disbelieve it. Even myself. I didn't even like him neither. And unfortunately, that is a big lesson I learned here. My personal feelings should not be involved within my work. I personally dislike him, and I didn't like Hillary neither. So what we get is wrong. And on the last day, we adjusted a little bit of our parameters, and then we got it wrong. In the last day, on the 7th of November. And this is the mistake we got. That is the others we called. We cut it off from our predicted votes for the Trump to the media, to the uncertain or undecided. And that is a kind of mistake. I summarize this into a few points. Firstly, it is rationality against the emotion. The secondly, it's a negative against the negative. So if you are negative to one party, it doesn't mean you will be negative to or positive to another. So double negation doesn't imply a positive here. And personal characters versus political issues. That is another problem we had in our counting on the votes. And finally, here is my biggest lessons. Sentiment is reactive, but opinion is proactive. If you read those textbook about opinion analysis, they said sentimental analysis is interchangeable with opinion analysis. But since this, I feel sentiment is reactive, but opinion is a kind of suggestions. Got a specific sentence about an object and your adjective and your attitude. So we would say opinion is more towards proactive application. And that means sentiment is talking about the personal characters. The opinion is talking about political issues. Yes, please.
Is it only Twitter data?
It is Twitter data, yeah. It's about one.
Can you use Facebook or something else? Because it's got a...
Facebook, we would love to use it, but we can't get it. We can, but not legally, so we didn't use it. Definitely. Definitely. My student actually got a lot of Facebook data. Then I stopped him. He said, that's easy, we can do it. I said, no, sorry, we don't do it. Okay, we can definitely get it. Yeah, it's not technically it's not a big deal. But we are not supposed to do it because Facebook has a very expressive sentence here. We cannot.
They also have an API to provide for people.
Facebook doesn't. Yeah. Twitter has. Yeah. Facebook got a little bit because they have a public account. If it's a Facebook public account, they would allow us to do it. Yeah. But for private account, you cannot. Yeah. Officially. Okay. Yeah.
Doesn't Facebook have a lot of private votes?
Yeah, a lot of things. Instagram and there are other things. I don't want to discuss those things, not legal. Okay. Yeah, so technically it's not a big deal. Really, because we start a lot of network security, this is another issue. And I can show you a lot of horrible things could happen on your computer. Yeah, but this is a different talk. Yeah.
So is the data set broad enough to get an accurate picture of the...
That was what I said in the beginning. According to Pew Research Center, 75%.
Really?
Yeah. It's surprisingly high. Yeah, because the range of people now is from 10 years old to 75 years old. Yeah.
So a data set for an industry like agriculture, would that still be, it depends on the size of the data users or the size of the user?
This depends on the distribution of the data. Yeah, like election data, you have to collecting the historical data and then adjust your prediction based on the sentiments. And you have to normalize it. Yeah, normalization is based on the distribution of the data. Yeah. It is not very, very accurate. But for predicting election, I believe it is accurate. For financial market, there is the website called Kensho, K-E-N-S-H-O. It was 28 years old, University of Illinois computer science graduate. He established this website, and then predicting on the Wall Street stock market, and very accurate, continuously. And then the Golden Shark bought it and shut it down. You see, now he's an employee of the Golden Shark, and that's just little bit of work after graduation ceremony gave him $19 million. Yeah, for a 29 years old boy. You see, it is doable now, and the people are doing that. I put my ARC-DP application for predicting on the financial market data. I presented all of my plan for doing this. 5 reviewers gave me 5 positive feedback. Excellent. Wow. So I still didn't get it. I don't know.
When you give all the information from Twitter, would you have specific sort of search terms that you look for?
Now we do the streaming.
How do you get all that?
We do the streaming. Streaming means we download everything. Then we establish a network of, for example, in Australia, there are about 3 million Twitch accounts. Yeah. Many of them are just tweet once a year. Some of them tweet frequently. And then we watch everybody, every post for everything, anything they are doing. Sounds very big, but it's just 10 giga a day. Sorry?
How do you extract the ones that are relevant to what you're looking at?
Using API, Python. You can download the open source API from Python and crawling on the Twitter. And there are very different ways to do that. If you do that exactly, follow their instruction, you can get on 15 tweets per hour. That's horribly small and slow. We are using streaming means you can download a few 100 million as long as your network is fast enough. Then you just keep downloading anything, everything. Then you do the filtering. And then you get the accounts, and then you go to pin for that specific account. And we only pin the active account.
Around what you're interested in. So with Donald Trump and Hillary, you'll have some filtering. And how do you decide on the filtering? Do you just have the name, or do you have what do you have?
As you can see, it is on our website. We identify 17 issues. Arms control, birth control, sex, home sex, marriage, this kind of thing. We're collecting the keywords. Firstly, we collecting every word, and then we say who is talking about what. We call the language model again. Yeah, Donald Trump got a language model. Hillary Clinton got her language model. The supporters get a different language model, and then we do the head counting after that. Yeah, we find out which side you are first, and then we count on the votes, possible votes. Yeah.
What is the other big source of information you're using?
Sorry?
Twitter?
No, we can't, because we are not commercial yet. So if it's commercial, we can get a lot of different types of data. Yeah, I hope. The thing we are doing is called the opinion search engine. This is just one of the applications from that software. And the opinion search engine is going to be transparent. So every organization, you can have that like a Google search engine, but we call it opinion search engine, installed on your website. You don't see us, but we are working for you. You're collecting opinions about your organization. For example, if you care about UQ, care about Brisbane City Council, care about some kind of brand name, Coca-Cola, I would go all world to search anyone talking about you and summarize for you. Yeah, that is what we do. Okay, so this is the lessons I learned. And this is, we call the language model. What's that mean? So if you have two different political parties, we use the pixels to denote their emotion or their feelings. And they're positive towards one party and probably negative towards other party. And then we figure out the actual words they are talking about. And then to figure out the co-occurrence of those words frequently appeared, and then combining with the sentimental analysis, and we can do the evaluation and which party is winning. And we got a patent on this. So it is a kind of very, how can I say, very accurate method. As long as so far we got a 95% accuracy in predicting on the elections so far. Yeah. And this is the idea. So people talking about topics changing over the time. And over the time, there are a set of words which stay on. And then that is the language model. And then from time to time, we combining that and do the predictions. And let's just continue our talk about this for what we are producing now. Firstly, we summarize the current social media or social networks are doing this kind of connecting, let people sharing experiences, socializing. And there are different contents and different players. That is the situation we are dealing now. What we are proposing here is called the social media 2.0. In that case, we want to let people not just sharing the experiences. We want to share the values together with the sharing of experiences. If you have a good experience, then we should bring your good value or good services if you have a good experiences based on your social network. Let's just see what kind of people's feeling would affect the performance. Reputation of the bank. If a lot of people don't like a bank, this bank business will be affected. House pricing. If people say, wow, we need to buy, and then people's feelings will affect the house pricing. Government elections, tourism of the country, and fashion products, for example. Now we look at the current situation. On the one side, you can see the person sitting there, look back at the social media, and they get some experiences, and then doing businesses individually with different service providers. That is our current situation. What we are proposing is like this. You have one platform. You are associating your friends within the social media and sharing your experiences. And then you do business directly with those service providers. In this case, you must solve one technical problem. That is, you need to own your own data. Once you are going to hospital, finish, I own my own data lifetime. If I do some booking on Qantas flight, after that, I do the booking from Virgin Blue or from South China airliner. That experiences and that history of my booking should help me to get a better deal with another service providers and to share with experiences with my friends at the same time. So that is, we are proposing this kind of framework, and we are doing kind of a prototyping to demonstrate how can you do that. And that is the definition. We say, okay, social media have a kind of vision. That is, data is a value. This is a place sharing experiences together with sharing of the value. This one-stop platform connecting services with consumers. And the last one is we need to connect the social media with the Internet of Things. And this is a key features, and this is what we are actually doing. Data flow, workflow, and the cash flow to look after the different levels of complexity. And this is an example from the social media connecting with IoT. And that is about the people in China migration during a certain time period. And every dot here is a metadata about a mobile phone available from Chinese telecommunication. This system is not mine. I copied this from the highdata.com company. And here is another big data application from High Data company. It's a flight information about all the flights over the Earth at that moment. It is 24 hours available, and every dot here is a flight in the air, and the summary of the all over the world of those flights for this company. And the next one is a Chinese social media. Every dot here is opinion. We need a big ranking algorithm to rank the most important, most influential, most dangerous, or the combination of those most something, most urgent something. And then we combine those messages posted on the social media and then allow people to have a quick understanding on the whole situation. And that means the social media should be connected with the Internet of Things. And this is our current platform we are doing. On the top of that is our search engine. We call the opinion search engine. And this is what we are doing. On the bottom of that is we call the X data and the polymorphic databases. The X data is not my idea, it's DARPA's idea. And it is similar to the blockchain or Bitcoin. If you know what is a blockchain and what is a Bitcoin. And the X data has a similar idea from the DARPA, which invented the Internet. Okay. The key issue here is to solve the ownership of the data and make data availability for every stakeholders. In future, people say there is no more data center. All the data centers will become the storage center. It's not a data center anymore, like a lockers in the train station. It is a place, put your data there, you pay for it. It's a big storage center, not a data center. So-called open data policy, it is actually look back. Because so-called open data, what's that mean? That means historically, you collected a lot of data sitting on your machine. You don't know how to use it. Then you say, okay, I do the open data. The biggest problem for open data is noisy. We spend a lot of time trying to understand those open data sets, understand their metadata, and try to do the cleaning and make that structured, and then we do the data fusion, connecting everything together. Why not? We start from beginning. When people create the data, the ownership will be assigned immediately. The creator of the data will own the data. So in future, we don't have even open data. Everybody owns their own data. And then we come together and we share each other. We authorize data usage to each other. So that is X data as a kind of opinion. So what I see is there is a silent revolution. Just started last year. Together with the big data applications and big data scenarios. And the X data is going to be one of the big impacts after the Internet. And we are trying to catch up this trend. And then we have our architecture designed. Polymorphic database is another issue. It's coming to us a big issue as well. So if you know what is called the Spark, I think many people are using Spark. I will tell you, discuss this a little bit more. Before we go to the details, let's just say what happens. You want to get a service, you got some experiences. Then you talk to the online, you still don't know what you do, and then your friend, your experiences, and people's comments, people's opinions come to influence you And that would help you to make a decision to take the services online. So this is what we are trying to do. And and this is the actual our opinion search engine function. If you know what is a big table from Google search engine, they store the whole internet World Wide Web into something they call the big table. For us, we call it big O table. That is the function we are doing. So what we are really doing is in this picture. You get a tweet from the social media, and then we do the classification. Who is this? Who is posting this message? Who is this guy? Which political party he's voting? Does this person like iPhone? Does this person like buying second-hand Toyota car, for example? So we are doing this kind of classification on who they are. Not necessarily to know this person's real identity. We just do the profiling. Secondly, what this person is talking about. Talking about the University of Queensland, or UQ, or Melbourne University, or talking about the government, or talking about the election, or talking about some issues. The thirdly, what is the opinion this person is talking? And fourthly, at what time? And lastly, it's about where located. And each one of those variables is a matrix. There is an ontology based on that. For person, there is a person-to-person relationship. This is a network. There is a retweeting activities, the follower of somebody's. For the topic they are talking about, it was University of Queensland has a research, teaching, student on-campus experiences, a lot of things. For restaurant, you got a price, service, environment, and the quality of your meal, for example. For Z, opinions is not necessarily negative, positive, or unknown. You can actually have a recommendation. You should do such thing. You should make your parking free for your customers, for example. And then we do the structured opinion here. We call the structured opinion. I got a 1 PhD doing specifically this topic. And the next one, T, is to track the events in a certain period of time and see the changes up and down of those opinions or changes of people's opinions, and at a specific point or at a time period. The L, location could be in different granularity, like Australia-wide or Queensland-wide or in St. Lucia campus. And this is what we are storing on the big O table into a structure we call the polymorphic database. This is not my invention. This is a new concept. A lot of people are doing this. So we just catch the state of the art of the big data processing architecture. It's called the polymorphic databases. Traditionally, we have a relational database. We have a data warehouse. And that is store the data by rows, row by row, horizontally. After that, people feel, wow, this is no good. Because a lot of time, we want to search for some specific value in the tuple, in the record. If you bring up the whole record into the memory, that's too expensive. Because we are only looking at his salary, for example. So people invented another type of database. That is a column database, if you know what I'm talking about. MongoDB, Calandra, those kind of databases. They store the data in terms of columns. They said, wow, that's good. We only store a single column as a single file, and then we can search much faster. But however, there is a biggest problem for database technology or data processing technology. That is join operation. The join operation is the most expensive operation. Doesn't matter which one you are searching for. In the end, you need to join the data together to find out whatever you are looking for. So neither row-based storage or column-based storage is no good, has their problems, because they are looking at the storage on the secondary storage system. That is on the hard disk. On the hard disk, you can only have one approach, row-based or column-based. That's it. One of them, not both. But how can we do both? Now you see the keywords here. In-memory computing. Because the memory is so cheap now, we can have, let's say, 24 terabytes memory in RCC, in UQ. There is a research computing center. You can have 24 terabytes data in memory. That is in terms of nanoseconds. On the hard disk, it's microseconds. There are 3 orders of magnitude differences. So in-memory is our keyword. We put everything, doesn't matter it's row-based or column-based, into the memory first. What do we do? Then you do access of your data, either column-based or row-based. Up to you, up to your application. Because within the memory, addressing system is 2-dimensional. Not like a hard disk. You go the cylinder, you go to sector, and then you go the offset within the sector of the cylinder. I spent a lot of time on that. So why not we make every piece of data within the memory and deal with all possible joins, even pre-join them if they are most frequently used. And this is the idea of polymorphic databases. It's not my invention. We are just following the state-of-the-art technology to make those things as a state-of-the-art research. This is our user interface, or we call the dashboard. So if you have an opinion search engine, everybody has their own interest. Whether you are going to zoom in, zoom out, to look at the people's opinions, or you are going to look at the restaurant in terms of its structure, services, prices, or looking at the iPhone, they all have their own ontology. So it's a top-down tree-structured ontology for those topics or objects you are exploring. And also on the timeline, you can move the time bar up and down to do the tracking on the events, on the hottest events. You can do the top 10 ranking on the most influential topics, most urgent or most something, or combining of them. You specify them. And we call this as 6 different drivers for users of our opinion search engine. And of course, you can explore the relationship between the users. And then we give you the network of those users. So 3 million of Australians working on their Twitters. Sounds big. But we watch everyone, every piece, every information in the memory is just less than 1 terabyte data. The computation is very expensive, of course. But one day data is, comparing to the memory capacity, is pretty small. So don't think about, we can monitor the whole country, but it's computationally not a big deal. Yes?
It would be then biased if you only collect Twitter data.
Yes.
Because
I agree.
particular kind of people may use
I agree.
and not others.
I only have $600,000 doing this. You give me $2 million, I can do much better job. Right? I know it is biased. I did my best. There is a D2D center, Data to Decision CRC Center. They invited me to go there last week in Canberra to the government. There were hundreds of, about 100 government officers and the D2D center, CRC center. You know how much money they got? $92 million in Adelaide, and in Adelaide, this center.
What money can do with the, money can't get you the Facebook information.
You know, they spend a lot of money doing one thing. I tell you, they did spend a lot of money doing one thing. Pay the check to the Twitter company, pay the check to the social media company, get every piece of posting from their users. I don't have that money. It's about $300,000 a month or something. $1 for 10,000. $1 for 10,000 posting. Yes?
Is it possible to adjust for device? Means those people who use Twitter may have some particular quality.
Yes. Yes, I do. I believe there is a bias. But what I can do?
But then,
I agree.
But then you are also taking into account the past results. So you are only using
Twitter
data as a kind of...
Yeah, I have a PhD student is going to do with image data, video, what's called the micro video. There's a flash video for 6 seconds. And there is another social media do what's called the Instagram, which has a GPS location, actually. Yeah, we are doing that, but with the minimum spending. I have $300,000 ARC. I have about $800,000 from ARC linkage, plus close to $1.5 million plus $600,000 from UQ. It's nearly $2 million we are doing this. Okay, still not good enough. Okay, yeah. Okay, so this is a big business, but we are limited on this kind of resource. And this is our computing platform. And And this is just computing architecture. And this is our actual framework. And this is a scenario, what we are doing. And this is software system architecture. On the bottom, you can always say this is in-memory computing. We put everything within the memory. It's a terabytes allocated. We have 5 machines. Each one of them have 1 terabyte memory. And put together is a cluster. We also ordered about 32 nodes. Recently, we are going to have a big data lab in our group, and which we will have more than 10 terabytes memory. This is our software architecture. As you can see, we use Sparkle and Spark, and those things. I think that's. Let me just go through a little bit interesting stuff we are doing. We invented something called the spatial temporal word spectrum. That is a set of frequencies about people's behaviors on the internet, on the social media. We call it linguistic fingerprints. We find out fingerprints. Everybody, anybody, as long as this body is talking about something, we create a unique signature for that. And then we can use that to analyze the behaviors of the social media users. That is when people go to bed. In Brisbane, it's 10 o'clock. Sydney, 11:30. And Toowoomba, I think, is 9:30 or something like that. Yeah. And this is about people swearing. At Tuesday morning, 10 o'clock has the highest swearing time. And every morning, 10 o'clock is going to be like that. I don't know why, but I guess some people told me this probably is a tea time for people, and then they can have time to do the tweeting. And that is a kind of situation. And this is our actual spectrum, visualized spectrum. At Melbourne here, 3000 is a postcode for Melbourne, and which has 3 o'clock, for example, we have a highest frequency talking about dogs, and that is the time they walk the dog. And this is a frequency of the certain words in 24 hours. So it's up and down for every word. And the language model is along the time will change from time to time. The reason we use this is very significant. Let's just show you. For example, in the evening time, at about 8 o'clock, people talking about the police, drugs, in this frequency, normal time. But in a certain day, when people talk about the police and the drugs, has this high frequency in the certain time period, and then we know something must have happened. And actually, very accurately, we picked up. There was just 20 tweets. It's not a big number, not hundreds or thousands. Just a few of them, suddenly, police, drugs come out much higher frequency in that certain time. We picked up. So that is a very sensitive sensor, social sensor on those kind of events are happening within the social media. And this is about social communities against the topics people are talking about. So we have two different perceptions. Given topic, you want to know who are the people. Given a group of people, we call the communities, you want to know what the topics they are talking about. So it depends on which perception you are looking at those things. We constructed this graph and try to do the prediction as well. That is our part of our opinion search engine. And then we use that for prediction on the emerging events detection, location sensitive, and London Royce, we did the testing on that. It is accurately predicted. And this is frequency. We do the election. This is our user interface. This is our user interface. And we do cyberbullying detection. And this is the motivation why we do that. Those people are all committed suicide. They all cyberbullying, bullying attackers are their friends. They all use almost the true social media account name, and they all first-time users. So there are some characteristics or some features for those people committed suicide. And also, they don't talk to their parents. I did this research because about 6 years ago, my youngest daughter was typing something. And I said, "What are you doing?" And she suddenly covered the screen and said, "Daddy, what do you want to say?" I was scared because my younger daughter was 10 years old at that time. I don't know what she was doing. I asked her, "What are you doing?" She said, "I'm on the social media." And I said, "Gee, how could I know what she's talking and if there is something wrong?" Then I started this research. I searched for cyberbullying, for example. I was worried about my daughter. And suddenly I found out there are dozens of pictures, people committed suicide. 5 years or 6 years ago, there are about dozens of pictures. But if you do the search now, you got thousands of them. Every day people killed themselves. And this is just using Google search engine, you can find out that pictures immediately. And all of those pictures get a rest in peace, RIP, in their account. They didn't delete it. You can still see their accounts, but it's marked as RIP. Yeah. So this is the situation. And this is a product. Yeah, I think it's time up.
No, sorry.
The last one is about product opinions. If you search opinions about a product, and we will be able to tell you who would like the second-hand Toyota car, and who would like a certain brand of mobile phone, and those kind of situation. Yeah. Yeah. And this is one of our research, and this is our work, and this is a conclusion. So social opinion search engine is going to be a summarizing and a prediction. Data fusion, machine learning, and data visualization is what we are doing. And here is a list of our publications. Okay, thank you. I rushed through everything. I'm happy to answer your question if you like.
What platform are you using for the front end for your dashboard?
Yeah, okay.
What platform are you using for your front end for your dashboard? Are you using?
We're using the we call the Java and the Scala. You know Scala.
Yeah.
And the Spark. Yeah. And the Sparkle, we are using a different platform. It depends on which. We're also using R as well.
Okay.
Yeah. It's an integration of piece of everything. Yeah.
So R, isn't the R the bottleneck of the computational speed?
Yeah, the R is very, very limited on the memory, in-memory version. I asked the Yan Chang, and I said, can you talk about R a little bit about in-memory computing? He said it's not so good. So many of the classifiers, those algorithms, we did ourselves. Yeah. R is good for small, let's say less than 10 gigabyte data. Yeah. It's a pretty small one. Yeah. We are talking about hundreds of giga at least.
Are you using any sort of, I've got an agricultural background, farming background, are you using it for any of those applications at all? Or?
No, we basically do everything ourselves. Yeah, we are not using even this farming or this kind of thing.
Trying to find events or trends in
okay.
farming? Yeah.
We have a work talking about we call the invariant events. That is a set of keywords stay for a long time, for over the time and unchangeable. Yeah. Is that what's your question? I'm not quite sure.
Just what I'm just as an example. Commodity prices are supply and demand driven.
Oh, I see.
Sentiment involved with that.
Yeah.
So I was wondering, media. A lot of the processors side with the media to put out particular information to the market.
I see.
That dictates the price a little bit. So
I see.
So I wondered whether or not you've sort of done anything, with the cattle market or with say interest rates or something like that.
We didn't do much on that. Yeah. Basically our contribution is on analyzing text and the structure of the Twitter users. And understanding what they are thinking and make it searchable. That's it. I can say a few words. Yeah?
I was just going to ask about Twitter users because you can use it for a personal thing, but you can also use it for a product.
Yeah. There are a lot.
And there's different uses of Twitter. And the other thing is, are there any particular characteristics of Twitter users compared to the rest? Like, are they younger? Are they,
Oh, I see. I think so. Yeah, Twitter users are more focused on the certain issues, more openly available for public. But for Facebook, if you go in there, they talk about a lot of exactly which course you are studying, which park you are going, and the experience of traveling, making meals, and what you are eating, this kind of thing. Yeah, Facebook is more personal. Yeah, Twitters are more general. Yeah, interactive, I would say. Yeah.
Facebook is for the people you know, and Twitter is for the people you meet.
Yeah, they are different. Yeah, a lot of studies actually on this, comparing different social media with the different issues. They have but most of this research is done manually. Actually, access and record it. Yeah.
Sorry, do you treat retweets different?
Yes. Tweet and retweet means you have read it already, and we exclude those people retweeting everything. So there is a threshold about how many tweets you have browsed, and above that, how much percent you have retweeted. Cannot be very high. So if you retweet everything, that is nothing. So there was some kind of... we include means you are there are two kinds of network. One is a friend network, follower of a follower. Another one is you don't follow this person, but you read this and you retweet it. And this two network is overlapping in a certain degree, but not exactly the same. So we use retweeting for opinion analysis. We use the friend of friend network for the community detection and for propagation of the networks. And then we do the Monte Carlo simulation algorithms to simulate, because the real network is very big. You don't have even a chance to look at the whole network. So we do the Monte Carlo simulation and then present you only a limited number of the tweets and the users and extract the tweets. Most influential, most typical, something most current one, and the net people can see it. Yeah, that is we do. Retweeting is a very significant thing. Yeah, we do counting on those things. Yeah.
So you have this for English and Chinese, right?
For Chinese one, we can't do it because in Chinese people are all on the WeChat, and the WeChat. The Twitter analysis. Yes, we have. That's easy. Use Stanford NLP. They have Arabic, Chinese, English, German, and Russian. Yeah, 5 languages. Yeah. It's easy. It's not a big deal. We didn't do anything. We just used it. Yeah. Hi.
For opinion analyze, we noted that different people have different, we call it multiple coupling with the internet, because every people happy with something, they don't say nothing, and always the negative opinion is widely spread on the
Yeah.
The people, most of people don't have those opinions. So how your method can make some balance?
Yeah. Okay. Every opinion has another parameter we call the popularity. If people read your tweet, say nothing, even though it is a very hot issue or some news, like Steve Jobs dead or something like that, people still don't retweet it. And that is something we needed to look at. And some news probably propagated very fast. We actually did a computation. Over 300 million tweets. We're predicting every tweet, how many times people will look at it, and how many times will be retweeted, over how many levels, and over how many days. We did that. We own the first prize. Yeah, it is just statistics. Yeah, once you get a statistics, you normalize it and go to the model, and then you can answer a lot of questions. Yeah, I think you have to, in the end, you have to have your philosophy to doing things. Right? I had my wrong philosophy sometimes influence your result significantly. Yeah.
So out of that, can you actually create a language model on the best phrases to tweet, to get retweeted?
Yes, we do that. Particularly, it is very useful for detect the spammers.
I see, yeah.
Yeah. If a spammer, so far we can detect in very high accuracy, because spammer has a lot of things to do. You are paid to do it, so your frequency of a day is very high. Otherwise, who pay you? Yeah, and also the issues is variety. You're talking about custom, you're talking about food, suddenly you're talking about cars, and talking about political issues. And then you are detected. Then you say, okay, I cancel this account, I create a new account. Or I simultaneously operate 100 accounts, talking everything. And this one is for health, this one is for politics, this one is for sports. People doing that a lot. But we can find out, because we're comparing different language model. If you have your certain education, some words, you always use it. Some words, you would never use it. Yeah, because you don't know what you don't know, right? For me, when people talking about the denotation, connotation, first time to me, I said, what's that mean? Yeah, and when I check a dictionary, from that day, I can use it. So it's based on personal education, personal background, and personal experiences. And every language model is unique in the world. Yeah. And it's changing along the time as well. You can be better or something. Yeah.
So I'll just ask one quick question.
Yeah.
When you're talking about money, you were saying before, I presume you can buy, if you had enough money, you could buy a lot of Facebook. Is that right?
Yeah,
Or you
publicly available data from
only
Facebook.
publicly available,
Yeah,
not
yeah,
private.
yeah.
So
And by Twitter completely.
completely. So
Yeah, every tweet I can buy.
I mean, I guess it's been talked about here, but can you somehow adjust, if you know that the Twitter users are a certain sort of proportion of people, not necessarily typical, can you adjust and sort of
Interest the
sort of
search.
interpolate or
Yeah,
impute what the general public would
Yes,
think
yes.
about something? So you do that already?
No, we are not doing
But
that.
do you think you can, or are
Yeah,
you
yeah.
interested in doing that?
If you really have money, $1 can buy 10,000 tweets. And initially I got 6,000 to buy the tweets. But 6,000, you see, times 10,000 is just 6 million or something. But now we don't spend the money on that. We're just doing streaming ourselves.
Right.
Yeah, it's at least 1 billion every day. Yeah.
Well, if there's no more questions, and even if there is, perhaps, we might finish it there. And thank
Okay.
Xue very much for a
Thank you.
very interesting.
Thank you. I'm very lucky to come back. I used to work in the upstairs for 6 years. Yeah. 636, my office there.
And also, there's food and drink, and